We're going to write linear equations in standard form. This here is called standard form of a linear equation. So let's look at it. It means the degree, and I'm talking about the power here. They're both 1. Okay, and we're going to write these equations in standard form. So the x comes first, and I'm going to have to move this 2y over. So that's going to be 4x. I'm subtracting 2y from both sides. So I'm subtracting 2y, and I'm going to keep my 7 on the right side. Now, usually when I'm talking about this, I usually just say when you move something to the other side, change the sign. So if it's positive here, we're going to make it negative on the other side. If it was negative on this side, we're going to make it positive. So here, on this one, to write this in standard form, I'm going to have x. I don't have a y. I'm going to go ahead and make this 0y equals 12, because 0 times y is just 0. But I did write it in standard form, so it looks like this form right here. Now the y equals 3, I'm going to go ahead and put a 0x plus y equals 3, because 0 times x is just 0, but I did put it in standard form. Now this last one, all I have to do is move the y over, so I'm really subtracting y from both sides, because that will cancel, and we get 3. But in standard form, my a has to be positive. So what I do when I see something like this, I negate the whole equation. I say just negate, but it's really like distributing the negative 1. And all you're doing, you're making everything opposite. Opposite of negative x is positive x. Opposite of negative y is positive y. And the opposite of 3 is negative 3. So that would be in standard form, because your a always must be positive. In this case, our a is 1. There's not a 1 there, but that's what it is. Okay, we're going to graph some equations. The first two we're going to graph are these two. These are important equations, and I want you to know how to graph. So we're going to look at it like this. All right, so we're going to put over here, I forgot already, x plus 0, y equals 12. And if I only need 2 points to make a line. But let's let our x be 1. So basically what I'm going to do is, it says x is 12 everywhere, so I'm going to just put 12. It doesn't matter what my y is. I can make my y 1, 2, 3, 4. Because once you plug that in, 0 times 1, you still get x equals 12. If I plug in 2, I still get x equals 12. If I plug in 3, I still get x equals 12. So no matter what my y value is here, x is always going to be 12. So I go to 12. Here's 12. And I draw a vertical line. And that's that equation. So that is x equals 12. It's always going to be 12 no matter what my y is, even if that was negative 5. When you plug it in, it's going to zero out. Okay, the next one we have is 0x plus y equals, what was it? 3. Okay. That means no matter what my x is, I can make my x 1, 2, 3, 4. Whatever I plug in, I'm always going to get 3 for my range. And what it would look like is this equation here. This line right here. This is y equals 3. So my x could be -3. And it would still, right here would be 3. My x could be 0, and I'm still up to 3. My x could be 3 here, and I have 3. So all these points would be that equation. Okay, let's do the first one now. The first one was 4x minus 2y equals 7. Now, what I'm going to do here is plug in some points. I only need 2 points when I know this is linear. I know it's linear because my degree for x and y are both 1. So what I'm going to do is graph what I call the, what people call the X-Intercepts. I'm going to put a 0 here and a 0 here. So when I plug in 0 for x, I get 4 times 0 minus 2y equals 7. This is 0, so we get negative 2y equals 7. So y equals negative 7/2, which is negative 3.5. I'm just going to leave it like that. For my other point, I'm going to plug in 0 for my y. So I get 4x minus 2 times 0 equals 7. 4x equals 7, so x equals 7/4. It's very close to 2. If that was 8/4, it'd be close to 2. Now I'm going to go for x is 0 and y is negative 3.5, 1, 2, 3.5. So I'm going to put a big point there. And for x is 7/4, which is very close to 2, that's going to be at 0. So this point here is 0, negative 7/2, and this point here is 7/4, comma 0. Then all I have to do is connect these lines, these dots, these points, and I have my equation. Okay? Let's try one more. 8x minus y equals 16. Now you can plug in any points you want to get 2 points. You can plug in 1, 2, 3. But again, I just like to plug in 0 for x to get my first range, and then plug in 0 for my y to get my domain value. So when I plug in 0, I get 8 times 0 minus y equals 16. So I have negative y equals 16. I'm going to negate this because I'm solving for y, not negative y. And I get y. That means you just make everything opposite. So y equals negative 16. So negative 16 goes here. And now I'm going to let y be 0. So when y is 0, we have 8x minus 0 equals 16. 8y equals 16. So y equals 2. And I have my 2 points. That's all I need. So 0 goes down way to negative 16. So apparently I am going to have to go by 2's here. So it's going to be negative 2, negative 4, negative 6, negative 8, negative 10, negative 12, 14, 16. So here's my point, which is 0, comma, negative 16. My other value, since I'm going by 2's, this is going to be 2, 0 right here. This would be 2. So this is 2, this is negative 16, and this is 0 right here. And this would be 2, comma, 0. And I'm just going to connect the dots. And I just used 2 points, 0, negative 16, and 2, comma, 0 to draw my line because I know this is linear. And And that's all for this